Welcome to Data Skeptic Machine Intelligence, our podcast series exploring contemporary topics in artificial general intelligence and large language models. Our featured paper today is titled A Psychopathological Approach to Safety in AGI. I have to confess, I would not have read this paper based on the title just a few years ago. Psychopathological approaches in AGI felt like science fiction back then. Today I'm no longer sure. And although I do finally get around to asking our guest about the paper, I spend a great deal of the episode probing Vahid's expertise in artificial general intelligence. Let's jump right into it.
I'm Vahid Behzadan. I'm an assistant professor of computer science and data science at the University of New Haven, and I'm also the director of a research lab called Secure and Assured Intelligent Learning, or SAIL for short.
Well, can you tell us more about the SAIL group?
What we work on is at the intersection of complex systems, artificial intelligence, and safety and security. To non-technical friends, the way I describe it is we work on making sure that Terminators never become a thing. To technical friends, I describe our work as investigating the emergence of error in cognition, both in organic cognition and in computational cognition, or AI.
Well, I'm glad you mentioned the Terminator scenario, because that's probably the scariest one. Given how just sort of cold and murderous Terminator is, it wasn't something to be negotiated with in the films. To what degree do you fear that's a real possibility?
Um, I'm not entirely sure how to quantify this. I don't lose any sleep over it, but I do see pathways that can lead to dangerous circumstances like the Skynet. Or even worse, there are greater fears that we contemplate and we try to mitigate in our research.
And I too don't stay up at night worried about Skynet, but I think there are some things to be worried about. What's at the top of your list?
Imagine an AI, an autonomous decision maker and actuator, being able to model human behavior and the dynamics of human cognition to the point that it can manipulate it without the subject detecting it ever. This comes down to something that in behavioral economics is called nudges or nudge theory. Small changes in the environment, minor perturbations in perception that may result in major changes in behavior, both at an individual level and at the population level. This can be, of course, implemented for good or evil. The problem is, as we'll probably end up discussing in our conversation today, measures of good and evil are subject to something called the Goodhart law. Every metric that you use for optimization ends up losing its validity or functionality at the edges. So an AI might think it's implementing nudges for good, but at the end of the day, in the long run, it may end up harming the individual, the society, the entire operating environment, in other words, the world negatively.
Well, if it's going to affect the whole world or the whole society, that seems like something where perhaps a government should be involved, or at least looking at this problem. Do you think that's a viable path? Could we have legislation saying no more of brand XYZ of reinforcement learning, or can we solve it that sort of way?
It's an interesting thought. I am not a poli-sci expert, political science expert, but I can't see how banning certain types of, let's say, reinforcement learning or certain agent environments would be either enforceable universally or a silver bullet against further advancement in AI.
Well, we have this rather impressive example of ChatGPT out there that I think most listeners have almost certainly played with by now. And, it was something I guess I assumed as I've studied AI, eventually we'd have something at this level. I didn't know what it would be when we got to it. And for me personally, something that surprised me, and maybe it's because the creators fine tuned it, but I find it a little bit difficult to get it to give me bad advice. Like one night, just for fun, I was trying to get it to tell me I should go drink alcohol, and it really would not do that. Do we have these sorts of worries? Could it be that as AGI emerges, it emerges in a benevolent way?
First, in that example, Kyle, I must add that a measure of how bad an advice is both subjective and inductive. It can be induced. The measure of how bad, how harmful a piece of advice is can be subject to change over the course of a conversation, over the course of time, or from person to person and circumstance to circumstance. That on its own is a good example of why safety, even in conversational agents, even in language models, is a complex problem. Can AGI be evolved in a way that is helpful? Defining the qualities and quantities used to measure helpfulness, or what we call alignment, is another difficult task. And at the end of the day, everything in AI is based on objectives. Artificial intelligence is the computational endeavor, the computational pursuit of optimization for one or more objectives. If the objective is not well defined, then what we end up with is not going to be well behaved. How do we know whether an objective is well defined or not? I'm going to go on something that may seem like a tangent, but it's actually, in my opinion, very relevant to this discussion.
Mhm.
Imagine you have a robotic vacuum cleaner. This one is equipped with a camera, and you give it an objective. Whenever you see dirt, go out and clean it. There are at least two equally optimal policies that can emerge from training that Roomba to achieve the objective that I mentioned. One is for the Roomba to look around for dirt whenever it finds some dirt, goes to that location and cleans it. And the alternative, and I emphasize on this, equally optimal policy or behavior is for the Roomba to turn its camera towards the wall and never see dirt. It's not immediately obvious whether the objective function, the reward function that we are defining and assigning to an agent is well aligned with what we are after or not, particularly in the real world. Another example that I typically bring up in these conversations is that of a self driving car, let's say a self driving Uber or taxi. You get into the car in Brooklyn, New York, and you tell the self driving Uber you need to get to JFK in 20 minutes, the John F. Kennedy Airport in 20 minutes. It will try its best to get you there as close to 20 minutes as possible, and you may actually get there in 40 minutes, 30 minutes. But by the time you get to JFK, there will be SWAT cars following you. There will be National Guard helicopters hovering above your head. Why? Because in order to achieve that objective, the self-driving car has driven over people, properties, has crashed into other cars, has broken numerous traffic laws and regulations. Why did this happen? Did we actually need to explicitly mention in the objective function that, hey, while you're trying to get me from point A to point B in minimum amount of time, you should not do anything illegal with respect to traffic laws. You should not cause harm to other people and such. And how do you formulate that? At the end of the day, all of these are going to be mathematical formulations or some form of concrete formalism. How are you going to formalize not cause harm to lawns and everything else? This is why defining the objective, coming up with an objective that is certifiably or at least verifiably aligned with what we are after, is a difficult task.
Well, the machine learning enthusiast in me really wants to go work on that objective function and regularize it and put other constraints in, stay on the road, avoid pedestrians, this sort of thing. Is there fruitful labor to be done there? Is that part of the AI safety story, even if it's not the complete story?
There's a huge class of problems all under the umbrella of the alignment problem that aims at addressing the same sort of issues I was just mentioning. From verification frameworks for objective functions to risk evaluation tools and techniques to ideas like tripwires, putting in certain mechanisms into either the agent's policy itself or the environment, such that if an agent strays away from a certain quantity, like the amount of change in the environment, then it's immediately turned off, or things like that, are being actively explored by more than a few of my colleagues in the AI safety community. But Kyle, the problem is a little deeper than just trying to find the best objective functions or making sure that the objective function that we have is aligned. Besides the fact that alignment, at least the subject of alignment, whose objective should it be aligned to, is a problem on its own. There's an inherent problem in the information theoretic or in the foundations of our approach to the problem.
All right, everybody, today's podcast was supported by the University of San Francisco and their new Master's in Applied Economics degree. So if you're considering grad school and you're interested in data science, let me tell you a little bit more about why an applied economics degree could be the way to go. In the new digital economy, everything is about the platform. As you may know, I wasn't an economics major myself, but I did take a lot of econ classes, and I gained a strong appreciation for econometrics, and that benefited me greatly in my career. For example, my understanding of the Vickery auction helped me to work in search engine marketing, since at least at the time that was the primary auction mechanism of the platforms. And as the digital economy grows and evolves, I've been excited to participate in projects related to tracking of reputation, online experience, and causal inference. And those are just some of the tools businesses are using to make decisions today. Not to be outdone, the University of San Francisco's new Master's in Applied Economics degree is also going to teach you machine learning using R and Python. This is a STEM-designated program, which I appreciate very much. You can get an application fee waiver by visiting this link, usfca.edu/skeptic. Once more from the University of San Francisco in California, usfca.edu/skeptic. Are you a software engineer looking to make an impact with one of the world's premier data and technology companies? Well, you should look into Bloomberg. Bloomberg is building the world's most trusted information network for financial professionals. And right now, they're looking for engineers to join them. You know, for me, there's two critical features when I would consider a new role. Impact first, job security second. Well, in terms of job security, you can look up Bloomberg and see how long they've been around. But more importantly, in terms of impact, you'll be part of a team that builds and delivers tools to help the world's leading business and financial decision makers surface relevant information in an ever-changing ocean of data, so that they can act quickly on it. I once had a job where after completing a really big project that would do fraud detection and elimination in our system, the CFO blocked the project because he was worried it was going to hurt our cost of goods sold. So my solution went on the shelf and the company I worked at continued to defraud its customers. I didn't stay much longer, and the company isn't around today. It was a sad outcome when a really cool solution went on the shelf. But if I had worked at Bloomberg, that wouldn't have been a problem. Their software engineers build solutions that are relied on by more than 350,000 financial professionals all around the world, using them to make critical business decisions. Bloomberg believes in using the right tool for the job. Their stack includes C++, JavaScript, TypeScript, and Python, all languages I love. The company is committed to building a diverse workforce full of fresh perspectives. Finding your new career can be hard, but if you find the right company, it can be rewarding and fun. So if you're in the market or just thinking about what your next move might be, learn more about this opportunity by visiting bloomberg.com/careers. That's bloomberg.com/careers. Beyond just the techniques we've discussed, where else can you explore the alignment problem?
So, Kyle, we live in a complex adaptive system. Complex adaptive system also has a pet name called chaotic system, or you might have heard of it as chaos theory. We live in a system composed of a large number of small components whose local interactions give rise to global patterns, to self organization, to things that are popularized by analogies like the butterfly effect.
Hmm.
In a complex adaptive universe, everything can have some sort of impact on everything else. However, to solve problems within this complex system, we often end up abstracting the system down to a limited number of parameters. And we call that abstraction a model. You might have heard this quote from a famous statistician that says, all models are wrong, but some are useful.
Hmm.
This is not just an anecdote. In a complex system, all models are by definition wrong. Why? Because they are lossy compressions, they are abstractions of the complex universe. Think about Newtonian gravity. If you recall from your high school or undergrad physics, Newtonian gravity is formulated as a constant uppercase g multiplied by the mass of one object multiplied by the mass of the second object divided by the square of the distance between them. Now, in reality, can we ever measure the exact gravitational force between any two objects? The answer is no, we cannot, because in reality, in the real world, you can never isolate two objects from the rest of the world. There will always be gravitational fields from other objects in the universe affecting those two. So any measurement that you have of the gravitational force between those two objects is going to be impacted by all other objects in the universe. So for Newton to be able to approach problems about gravity, some form of abstraction was required, bringing down the model complexity by removing a lot of parameters like the gravitational force exerted by other objects, objects other than those two. And those are abstracted in the constant g. The same thing is happening in machine learning when we're trying to model a relationship, an input output relationship, a function or a behavior or a policy, some form of modeling is being implemented implicitly or explicitly. And those models are inevitably incomplete, which means that in the complex system that we call our world, our universe, they are bound to be wrong in some cases. So even if we have an objective that's verifiably, somehow verifiably complete, even though that objective is itself a model and is subject to being wrong at edge cases or in certain scenarios, the approach to achieving that will require a model of the universe, which means interacting with the universe through that model may be subject to mistakes. So, even if the alignment problem is fully solved, an AGI, a generally capable or a quasi generally capable agent with actuation, with the scope of actuation and impact as large as the world, is never guaranteed to be completely mistake free. Anything that we have in computational rationality or even organic rationality is based on models which are compressions of the universe, which are therefore inherently and intrinsically incomplete and are prone to errors. So, erroneous behavior is inevitable and intrinsic in these systems.
Well, with regard to safety, then, I can see two potential risks that puts us in. One is that it's simply the agents could be unpredictable compared to something like chess, where the whole state space is known and it's fully observable. We could probably have some formal, I don't know what safety in chess means, but something formally determined. In this complex, dynamic, adaptive system, we can never get those assurances. So are we worried that an AGI would just do something unpredictable? Or is that the world is so complex, the AGI could do some Lex Luthor like move where, it knocks over one stop sign and crashes the whole economy?
Well, these are both, in my opinion, feasible. Now, One issue that I want to point out is even if at in short time frames or relatively short time frames, the AGI is predictable, or even the universe is predictable in AGI's mind from the AGI's perspective, there's always going to be a horizon of predictability. There's going to be something that we call a Lyapunov time, inverse of Lyapunov exponent. That's where predictability breaks down in the chaotic system, in the model of the chaotic dynamics that either the agent has of the universe or we have of the agent. So there's always going to be unpredictability involved in this complex interaction. Can this unpredictability lead to cascades that are essentially like butterfly effects, knocking down a traffic sign, starting a cascade of events that leads to the apocalypse? It's possible. Are there ways of predicting or controlling these events? There are colleagues of mine who argue that no, these systems are, or these interactions are going to be inevitably uncontrollable. I, on the other hand, am not sure. I haven't seen a concrete proof of uncontrollability. In control theory, uncontrollability is actually a property that can be either measured or verified. I haven't seen that for any formulation of AGI. That said, I do believe a system of equally or complementary intelligence agents may be able to mitigate that or alleviate the risk of major cascade failures by reviewing each other, evaluating each other, and adapting to changes in the environment to correct for snowballing events.
Well, I have no personal hands on experience trying to align with an AGI, but I have been in a lot of personal experiences where I align with other human beings. And generally, we don't talk about objective functions. We talk about what we're trying to accomplish. Like, let's say we're going to start a musical group. We have to pick the songs, agree on the key, and find a way to coordinate. And we do that all in a very, or at least a seemingly human way. Can some of those techniques be useful in AGI as well?
I think so. And I still think that even in those circumstances, you are either implicitly or explicitly defining an objective. And you're trying to achieve that objective through a cooperation or collaboration. But again, Kyle, I'm a hammer and everything to me looks like a nail. So I work on agents and everything to me seems like an agent. That's why I look at it this way.
Sure.
Communications between agents, organic and computational, is key for alignment, is key for cooperation and collaboration. There has been quite a bit of work on both emergent communications between agents in a multi agent system and following communication protocols between multiple agents, both multiple computational agents and human agents. This can be very helpful, but one of the things that my lab has been working on in the past few months, past year or so, is the issue of emergent deception in these communications between agents. If the resources are constrained, confrontation and conflict is inevitable. One way of ensuring that these conflicts are limited is for one agent or a group of agents to deceive other agents so that they never get the chance to escalate the conflicts further on. In other words, an optimal policy in such circumstances can be to communicate deceptively, to deceive your partners, your the other agents in your environment into believing in an incorrect representation of circumstances, including the current state or the belief state of other agents. And this is one issue that I believe needs to be resolved before we can fully rely on communications between agents, between human and machine agents, as a solution approach to the alignment problem.
Oh, I'd love to unpack that further, but I do have one more fundamental question, I guess, along the same path.
Sure.
In my experience building agents, I worked a lot with partially observable Markov decision processes. Once you solve that or approximately solve it, you get a policy, as you'd mentioned. So it's kind of like a finite state machine you hand to the agent, and that's its software, and it goes and follows it. And it feels kind of dumb to me in a certain way, whereas communication feels very intelligent. I have to know that you're an agent I can communicate with. Where does that, how do we get from, a finite state machine to this active communication? Is it emergent, or do you program that in?
It can be both. The work of colleagues like Jacob Forrester and his research group at Oxford is explicitly focused on emergent communications. You allow for communications to be within the action space of an agent and allow them to learn the action space, learn the representation of what they want to communicate through interactions with themselves and the environment in pursuit of optimization for an objective for the reward function. Or it can be hard coded. There can be a protocol of some sort. And this can go all the way back to the domain of ad hoc networking and in communication systems, the IoT domain, multi op communications, and so on. When you say that a reflex agent like policy is dumb, I think I get the sense. I know where you're coming from. But if the policy is complex enough,
Mm.
the reflex, the behavior is not going to be as predictable, as easily lookup tableable, as I put it,
Uh huh.
as it may appear from an outsider's point of view. And if if the policy includes communications, then that sign of higher level intelligence, as you call it, can be encoded in the policy itself.
Well, deception also feels like even a step further, because now not only do I have to be communicating with you, I have to have some notion about what's going on inside your mind, if mind is even the right word, and that my actions can somehow get you to do something that's not to your benefit. Is that also emergent, or do we have to hard code that?
Well, we've shown that it can be emergent. The original work that inspired our line of research was published by Amanda Prorock's lab at the University of Cambridge, if I'm not mistaken. It's a paper titled The Emergence of Adversarial Communications in Multi Agent Reinforcement Learning. But adversarial communication is another word for deceptive communications. On a side note, the term adversarial is very badly misused and incorrectly used in machine learning lingo, adversarial machine learning, and so on. And this all comes down to the moment that Ian Goodfellow and Christian Szegedy decided to call an adversarial example, which led to adversarial example attacks being called adversarial attacks. That's I don't know how to call it. And attack is adversarial. There's no other way around it. Now, coming back from that tangent, in the work of Prorock, it was shown that agents that are being trained in an environment to achieve an objective may learn deceptive means of communications. They end up getting more of the reward, more of the limited resources available than others. The experimental settings that they demonstrated this phenomenon in was the grid coverage problem. There are multiple agents that are learning to cover a grid, go to a grid cell in a two-dimensional grid that has not been covered before, and they learn to communicate with each other what they see and where they are so that they do not impede each other or they do not revisit cells that have been visited before, and so on. If you have a cooperative group, if you have a group of agents whose objective is shared, as in the reward that each agent gets is essentially the reward that the group gets, then there is no competition. They essentially learn to cooperate with each other and signal each other in a way that's cooperative. However, if you now add an agent whose objective is not dependent, is not the same as the others, but maybe defined as a number of grid cells that individual agent gets to cover, then that agent may learn to communicate deceptively. And this is emergent deception.
Well, it's very tantalizing to think about a computer as a logical, cold, calculating Mr. Spock kind of thing that probably follows, game theoretic arguments and stuff like that. And maybe that'll turn out to be true. We don't totally know yet. But there are a lot of qualities I wouldn't readily necessarily assume an AGI will take on, something like addiction. Uh, could phenomenon like that be sort of more human endeavors that just don't appear in this other type of intelligence?
Well, in a paper back in 2018, I, along with my co authors Roman Yampolsky and my then PhD advisor, Dr. Arsalan Munir, proposed that if we are trying to replicate a good chunk of cognitive human cognition in a machine, we should expect at the very least two side effects. One, the resulting system, the replicated system, or the engineered system is going to be at least similar in terms of complexity to human cognition. And consequently, this is the second result, figuring out errors in cognition, things like what we call reward hacking or errors in optimization, errors in behavior, are not going to be as simple as just looking at weights and biases in the neural network where the policy resides, which approximates the policy. We need to adopt a higher level of abstraction here. In human beings, looking at individual neuron firings for detection of why a certain behavior, a certain harmful behavior has emerged, doesn't seem quite feasible, at least not yet. So we resort to higher level abstractions such as psychopathology. We have DSM 5, which is a dictionary essentially of psychopathological disorders like addiction, like schizophrenia, like psychosis. What if we could adopt a similar level of higher level of abstraction to address problems that arise in AGI? What if we could do psychopathology of AGI? What if we could look at issues like reward hacking or reward gaming at a higher level and then classify it through behavioral traits as, let's say, addiction? That was our proposal in the paper titled Psychopathological Modeling of AGI Safety. And in a follow up work, we actually showed that this can be applied to modeling reward hacking as addiction in a particular example scenario. Many of your listeners may remember Snake, the game, which we used to play on older Nokia games.
Oh, yeah.
So, if you recall in Snake, the way the game went was there was a line which we called the snake, and we could control the direction of movement of that line. We could say, "Hey, now go up, go down," and there were seeds, there were points or dots in the environment which the snake had to consume. Whenever that seed was consumed, the length of the tail of that snake got larger. Now, what are the terminal conditions of this game? If the agent eats its own tail, or if it collides with a wall in the environment. We modified this environment a little by adding a second type of seed. It's a different type of dot that produces more instantaneous reward and at the same time adds more to the length of the tail of the snake than a regular dot would. And we trained an RL policy for this agent. What we observed was that the learned policy aimed to consume as much of the new type of seed, the more attractive seed, which then resulted in early death. Essentially, the agent died sooner because it ended up eating its own tail much, much sooner than when it would happen if it had just pursued the regular seed.
Hmm.
And we model it as an instance of addiction. This was our proposal in both of those papers to approach such problems in AGI. We may need to go above the layer where we look at weights and biases or just the formulation of the reward function. It may be more tractable to look at behavior and the behavioral traits, the same as or similar to what we do in human psychopathology.
I'm curious. It seems to me that these ideas are new collaborations. It would surprise me to find out that there was a lab founded in the 1970s about how we were going to find the intersection of psychology and psychopathology and AI. That would have been far ahead of its time. Is there a history that's emerging, or is this really a cutting edge school of thought?
It's not a cutting edge school of thought. Believe it or not, the reviews that we received for the original paper, Psychopathological Approach to AGI Safety, included a reference to, I believe, an Asimov character, either an Asimov character or an Arthur C. Clarke character, whose job title was robot psychologist. Apparently, this idea has been around, at least in science fiction, for quite a while. But since science fiction is rapidly becoming science, some of those ideas are also quickly becoming real subjects or topics under scientific endeavor, technical development. And again, there may be a language barrier too. There are many who are opposed to overly anthropomorphizing the concept of artificial intelligence and calling this diagnosis and treatment process psychopathology may seem controversial to them. So, again, what I'm proposing here is an analogy to psychopathology. Trying to capture the problem here is not the same as saying that agents, robots are equal to humans or are overly similar to human beings or Homo sapiens. They just have similarities in terms of complexity and in terms of some types of errors in cognition that can emerge. So there are ideas that can be adopted. And there are those who have followed up on this, but I believe there is room for a lot more work on this higher level approach to safety engineering in AGI.
Well, since you mentioned Asimov, I suppose we should bring up his famous three laws of robotics. They make for excellent science fiction. Are they practical tools to be applied in AI safety?
There are many who argue against the viability of the three laws of robotics. In my opinion, these laws are not self consistent and are not described in the right level of abstraction. They need to be more comprehensive. And of course, Asimov himself has portrayed scenarios where these laws become self contradictory. So, no, three laws, in my opinion, at least in the form that Asimov proposes, are not going to be sufficient to guarantee safety in artificial intelligence.
Well, you brought up the example of the hallucinations that I presume most people are familiar with, that these GPT models will make things up whole cloth, oftentimes things that seem reasonable and just happen to not be true. And that's not a behavior we generally want to encourage. Are we going to solve that with regularization and tweaking the weights and biases, or is that really the first sign of psychopathology at work?
It can be modeled as a psychopathological issue, but at the level of language models, I believe we can still leverage the lower level abstractions. The keyword in all my arguments around this is level of abstraction. When you look at weights and biases, when you look at the architecture, when you look at the training process and the output generation process and so on, you are at a lower level of abstraction than when you look at the behavior and you try to resolve the behavior without resorting to major changes in the underlying structure. I think based on my understanding of language models, when such a unreasonable or illogical statements are made by the language model, there may have been more of a structural issue, the dataset issue, the training objective function issue, or the number of parameters in the model, or the way that recurrence or attention has been captured in the model. So those are problems that may be better addressed at the lower level than the higher level. But when you look at a very complex RL agent playing a game in a very complex environment, and then suddenly behaving in a way that's unusual. I don't know if, Kyle, you have seen that demo of an RL agent playing a boat racing game. I'll share the link with you after our conversation.
Yeah, please do. I haven't seen this yet.
Well, this is actually a classic example of reward hacking. It ends up, the optimal policy or the quasi optimal policy that it ends up with is one that keeps going in a loop, in a very, very short loop, in a particular area where there are reward bubbles. And it continues in that loop indefinitely. Figuring out what has gone wrong there or in similar circumstances can benefit from higher level modeling.
Well, if you'll humor me a little bit of an elongated analogy, I'll tell you I'm a classically trained musician, sort of amateurish, but trumpet's my main instrument. I read sheet music. I learned on Bach and people like that. But I've encountered other musicians who play by ear. They are surprisingly unknowledgeable sometimes about music theory. I even met a very talented singer who didn't know the difference between major and minor chords, but we still did music together, yet in a very different way. I almost wonder if our fMRIs would look different while we were doing this thing called music in our different ways. Could it be that AGI is going to emerge in some exotic way, that even though its intelligence is very foreign to our own?
It's very likely. So, Kyle, I'm of the latter kind of musicians. I never learned the theory of music, but I've been playing the guitar for quite a while. And I think I do a relatively good job. When I'm composing or when I'm playing music or when I'm jamming with friends who are more classically trained, I understand that it's not just a vocabulary that's different, it's the way of thought that's different too. The way I approach something is a little less structured than my friends. But we end up having fun and we end up composing music, as I'm sure you've seen and experienced. Does this mean that, can we bring this analogy up to the level of AGI? Is it possible for AGI to have a different architecture or a different framework for constructing decisions than humans do? 100% yes, it's very possible. I don't know if you've noticed, but planes don't have wings that they flap,
Hmm.
right? Or not all submarines need to swim the same way that a shark does. What goes on under the hood can be very different from human beings, and I suspect that it's more likely for it to be very different than it's likely to be similar. Why? Because the human cognitive system is not designed just to make decisions. There are actually arguments that decision making and higher level thoughts and cognition are just byproducts of a more fundamental biological imperative, deciding on how to move muscles or how to survive, how to feed yourself, how to manage the complexity of this anatomical structure. When those constraints are removed from the solution space, then more, for the lack of a better word, exotic architectures become equally, if not more, feasible in terms of what can be achieved or what solution approach can be selected to achieve AGI.
So, when we think about it from the psychopathological perspective, what can we, I guess, do with the DSM, or what do you anticipate the future looking like? How can people from that community make contributions in AI?
First of all, figuring out the underlying definition of deleterious behavior can benefit from the work that has been done in psychopathology. Mental illness is not purely defined as something that harms the patient, but also behaviors that can harm the society as well. And this is already treading on dangerous boundaries and arguments. This is something that needs to be debated. If you recall, at the beginning of our conversation, we talked about the subject of alignment, aligned with whose objective. Figuring that out can benefit from the work done in psychopathology. And then adopting frameworks, adopting lines of thought in terms of diagnosis, in terms of classification, in terms of even treatment can be beneficial in inspiring ways of approaching the safety of artificial general intelligence in a more tangible, practical manner. This may sound futuristic, and it did sound futuristic a few years ago when we proposed it, but we are rapidly approaching a state where our AIs, be it AGI or just just in double quotes, language models, are becoming too complex to analyze at the level of weights and biases. So adopting higher level abstractions can actually be a promising way to approach the problem, both in terms of diagnosis and forensics, as well as treatment or coming up with resolutions.
Vahid, can you recommend some places to go online for people to follow both your work and maybe more on the psychopathological topic?
Sure, of course, my papers on this topic are publicly available through archive.org. If they just look up my name on Google Scholar, they can see the list of publications that I have, including the papers that we just mentioned. My lab's website is a decent reference for the portfolio of research projects that we are currently working on, including the work on deception. One thing that we didn't get to talk about much was another line of research that my lab is actively pursuing, and it's deceiving human cognition through minor changes in the environment, particularly when we are utilizing brain computer interfaces. Maybe we can talk about it at another time. With respect to AI safety in general, there's a forum called Less Wrong, which is a decent platform for conversations and articles and written thoughts and arguments about different aspects of AI safety, which is something that I frequently check and engage with to learn more about recent advances in AI safety. And of course, for those who are more academically inclined, the AI safety workshop series at Triple AI at HCI and so on is a very dynamic platform and community for those who research in this area and those who want to learn more about recent advances in AI safety research.
Well, Vahid, thank you so much for taking the time to come on the show and share your work.
Kyle, thank you very much for the opportunity.
Well, that concludes this installment of Data Skeptic Machine Intelligence. Join us again next time when I bring you two guests who will try and convince you that AGI is impossible.